Sorry, didn't know anyone would see that. Let's solve some trigonometric equations. What do you say? OMG, LOL, 3 tan of theta equals tan theta plus 2 when negative 90 is less than theta is less than 90. What? All right, so we've kind of done something similar to this when we did the inverse trig functions. We were like, where on the unit circle is the tangent equal to 1? And you would have to find all the locations on the unit circle where that happened. Now we're just throwing an equation on it. But this equation is essentially the same as if we replaced the tangent of theta with an x. So we made it 3x equals x plus 2. This would be an incredibly easy equation for you to solve. And it's the same steps. So first, you would subtract the x, which would give you 2x equals 2. And then you would divide by the 2, which would leave you with x equals 1. And that would be it if the equation was this. But we have a little more to do on top of that. But it's the same steps. So first we're going to subtract a tan of theta. And you don't always need to write this step. Like you could just actually do it and just go ahead and write 2 tan theta. But we'll show our steps for this one. 2 tan of theta equals 2. And then, just like over here with the x equation, we would divide both sides by 2, which will give us tan of theta equals 1. So we're looking for the areas on the unit circle where tangent comes out to 1. But if you look, they're just saying from negative 90 degrees to positive 90 degrees. Which here's negative 90 down here. Here's positive 90. So they're looking for parts on this section of the unit circle where the tangent comes out to 1. Now remember, tangent is 1 at that 45-degree reference angle. So here, the 45-degree reference angle, they're both positive, right? So it'd be positive 1. Okay, that's good. That's what we want. Down here, at the 45-degree reference angle, it's a positive divided by a negative. So that's going to come out to negative 1. So the only place on the unit circle in this equation between negative 90 and positive 90 degrees where it comes out to 1 would be at positive 45 degrees. Now, this range that they give you is what you're going to answer in. They gave it to us in degrees, so we're going to answer in degrees. So we would just say 45 degrees. Sometimes you might have more than one solution here, but do check if they are looking for it in degrees or in radians. We're going to try the rest without using the unit circle. We're going to use like that hand trick, remember? We'll try it out. We'll see how we do. 2 cosine of theta plus root 3 equals 0. And this is the entire unit circle from 0 to 2 pi. So we're going to have to get it down to just the cosine stuff. So we're going to have to subtract the root 3. So it would say 2 cosine theta equals negative root 3. What are you going to do with that 2 in front? You know you're dividing it. So we have cosine of theta equals negative root 3 over 2. Now let's think back. Cosine, Cosox, Chicago White Sox. We're looking for when the x is negative root 3 over 2. Now the x is negative over here in quadrant 2 and over here in quadrant 3. So those would be the only sections we would look. Now remember the hand trick. Cosine is your x, which would be your left fingers. So how can I have 3 fingers on the left? That's my ring finger down. So that represents a 30-degree reference angle. 30-degree reference angle in these 2 sections. So that would be 30 degrees here and 30 degrees here. So if we're looking for that actual angle, or a 30-degree reference angle in radians, which is what we need, how many 30s go into 180? 6, right? So it would really be like a pi over 6 degree reference, or pi over 6 referencing. So you can do this a couple ways. You can figure it out in degrees and then transform it into radians, or we could just figure it out in radians. If we know that we have a pi over 6 reference angle, and 180 degrees is 1 pi, we would have to do 1 pi minus pi over 6. And down here we would be doing 1 pi plus pi over 6. But when you're adding fractions, remember you need that common denominator. So this is like, up top would be like 6 pi over 6 minus pi over 6. And this would be 6 pi over 6 plus pi over 6. So 6 pi over 6 minus 1 pi over 6 would be 5 pi over 6. 6 pi over 6 plus 1 pi over 6 would be 7 pi over 6. So if you can do it that way, that's awesome. Otherwise, figure it out in degrees. So a 30-degree reference angle in quadrant 2, 180 minus 130 would give you 150 degrees. 180 plus 30 would give you 210 degrees. And then you would just need to convert those into radians. And honestly, if I was doing that, which is fine, these both have a 30-degree reference angle to pi over 6. So really you could say, like, if 30 degrees is pi over 6, 30 times what would give you 150? That's times 5. So that would give you 5 pi over 6. 30 times what would give you 210? 7. It would be 7 pi over 6. That's the way I usually do it when I'm actually doing these worksheets in my head. I figure out what the reference angle would be in radians, and then I just see how many of those reference angles go into the angle we're looking at. All right, this one is a toughie. In fact, it's so difficult, I'm going to move up a little bit. Whoa, all right, calm down, calm down. Find all of the solutions. It doesn't tell us degrees, it doesn't tell us radians, and it doesn't even tell us just on one unit circle. So we have to list it kind of with coterminal angles. There's a fraction here. There's a lot of fractions. I'm going to clear out the fraction. This is a skill we learn in Algebra 1. You can multiply the entire equation by a common denominator, and then there won't be any fractions. 2 and 4 both go into 4. So I'm going to multiply everything in this equation by 4. So we'd have 4 sine theta equals 4 times 1/2 is 2. So we'd have 2 sine theta. Ah, goodness. It's early. And then 1/4 of 4 is just 1. So now we need to get the sine thetas on the same side. So we could subtract 2 sine theta. 4 sine theta minus 2 sine theta is 2 sine theta, and then equals 1. Now we don't want the 2 there, so we would divide that. Divide both sides by 2, and you're left with sine of theta equals 1 over 2. Now again, sine, sinoi, that's our y coordinate, which would be our fingers to the right. We need to have one finger to the right. Whoop. So that would be a 30-degree reference angle. But we're looking at the y, and we want the y to be positive, so that would be in the top 2 quadrants. Quadrant 1 and quadrant 2. So a 30-degree reference angle in quadrant 1 would be 30 degrees. If you had a 30-degree reference angle in quadrant 2, that would be 150 degrees. So let's just list those first for a second. 30 degrees, 150 degrees. But it also includes every angle coterminal with those. So if we're talking coterminal angles in degrees, that would be like another 360. So the way we're going to write that is plus 360, but it could be infinite number of 360s. So we'll say plus 360 n, right? That could be 4 revolutions. It could be 100 revolutions. But that lists every possible coterminal angle with 30 degrees. You can do the same thing with 150, plus 360 n. Now we also are going to list this in radians. So think of 30 degrees. How many 30 degrees go into 180? It goes in there 6 times. So we would say pi over 6. We'll do the coterminal things in a second. If 30 degrees is pi over 6, 30 goes into 150 5 times. So that would be 5 pi over 6. Now we'll list the coterminal angles with radians. What do you call one revolution in radians? That would be 2 pi, you know what I'm saying? So just like here we said plus 360n, here we'll say plus 2 pi n, plus 2 pi n. That's as tough as these are going to get when they say list every possible thing and they don't put any limitations on it. So that gets tricky. Oh my gosh. Now if we, again, turn this into like x's, then you had sine squared theta is like x squared. Then you have minus 2 sine theta, so that's like minus 2x equals 3. If you had a problem like this back in the day, you would have to solve this either with the quadratic formula, completing the square, or factoring. Factoring would be the easiest way, but you need to get it equal to 0. So we would subtract the 3. And then you're factoring, thinking, okay, they multiplied a negative 3. So it has to be one positive, one negative. The only factors of 3 are 1 and 3. But to get them to add up to negative 2, it would have to be negative 3 and positive 1. After you got to that point, you would set up two equations, x plus 1 equals 0, or x minus 3 equals 0. And here you would subtract the 1. Here you would add the 3. And those would be your solutions. Now, just like before when we substituted in x for stuff, there's a little more to do. But that's the same first step, same all steps, really. We would subtract the 3 first. And then we would factor. Same factors. It'd be minus 3 and plus 1. But instead of x, we would just have sine theta. So we'll have sine theta minus 3 times sine theta plus 1 equals 0. And then we would set up our two equations. Sine theta minus 3 equals 0, and sine theta plus 1 equals 0. Now I'm going to erase this other stuff just so I have the space. All right, so here we would add the 3. Sine of theta equals 3. Here we would subtract the 1. Sine of theta equals negative 1. Now, if you look, they gave us the limitations from 0 to 2 pi. So it's in radians. Think of our unit circle. Everything is at most 1 away from the center on a unit circle. So they're saying the sine, which is your y, so they're saying the y coordinate is 3. That would be up here. That's not on the unit circle. So this is not even an option, because it can't be greater than 1 or negative 1, or less than negative 1, because that would go beyond the unit circle. Now this we can do. The sine, where is the y equal to negative 1? And the y equals negative 1 down here, right? This coordinate would be 0, negative 1. So where is that in radians? Well, this is pi. So remember this was pi over 2, pi, and this was 3 pi over 2. And then this would be 2 pi. So our only answer is the 3 pi over 2. Nice. That one was tough. That's as bad as they get. Wow, I think I've said that 4 times now. So this one we're going to have to factor as well. So we'll subtract the 3. This one's pretty similar to what we just did. So again, it ends in minus 3, so we know it has to be 1 plus, 1 minus. The only factors of 3 are 1 and 3, but we have to set them up this time to add up to positive 2. So it'd have to be plus 3 and minus 1. So we set up our equations. Cosine theta plus 3 equals 0. That one's going to be a problem. and cosine theta minus 1 equals 0. So here, we'll subtract the 3, cosine of theta. It's not possible for it to be beyond 1 or negative 1. So this one's out. Now this one you would add the 1, cosine of theta equals 1. Cosine is your x-coordinate. So where is the x-coordinate? Positive 1. That would be right here, right? On the unit circle. That's the only spot where x is positive 1. Now we're listing this in radians. So this could be listed as 0 or 2 pi. So 0 and 2 pi. Nice. You could say 0 pi and 2 pi, but 0 pi is just 0. Now we're going to have repeats. So these are kind of like extra practice problems for ones we did. We've done all the types of problems. 6 cosine theta minus 1 equals 2. Okay, we're trying to get cosine by itself here, so let's add the 1. 6 cosine theta equals 3. We got to divide that 6. 3 over 6 would reduce to 1/2. Cosine is your x-coordinate. So where is the x-coordinate? Positive 1/2. Well, the x is only positive in quadrant 1 and quadrant 4. So if the x is 1, that means we need to have one finger to the left of our put-down finger. So that would be a 60-degree referencing. So that would be 60 degrees here. That would be 60 degrees down here. So 60-degree referencing on quadrant 1 would be 60 degrees. 60-degree referencing on quadrant 4 would be 360 minus the 60, which would be 300 degrees. But we just did it in degrees. They need it in radians. So converting 60 degrees into radians. Remember, you see what it is out of 180. So 60 goes into 180 3 times. So 60 degrees would be pi over 3. Now if 60 is 1 pi over 3, 300 is 5 times 60. So you can just do 5 times pi over 3 and get 5 pi over 3. Nice! Woohoo! Man, we're knocking this out. Woo! Here we go. We're going to need those cosines on the same side. So I'm going to add a cosine to the other side to get rid of this minus cosine. So cosine plus another cosine would be 2 cosine theta equals root 3. Now we don't want the 2 there, so we would divide it. Cosine of theta equals root 3 over 2. Cosine is your x, and it's positive, so that happens again, quadrant 1, quadrant 4. Now this is asking for it in degrees. So quadrant 1 and quadrant 4, cosocks, your x, root 3, so we need 3 fingers to the left. That would be ring finger down, which is a 30-degree reference angle. So 30-degree reference angle in quadrant 1 would be 30 degrees. In quadrant 4, it would be 360 minus the 30, so it would be 330 degrees. That was a doozy. That was a doozy. Oh gosh. Root 3 tan theta minus 3 equals 0. Let's add the 3 to the other side, which would give us root 3 times tangent of theta equals positive 3. We're going to have to divide by that root 3. So tangent of theta equals 3 over root 3. Now remember, you can't have radicals in the denominator, so you'd have to multiply by root 3 over root 3, which would give us 3 root 3 over regular 3, and then 3 divided by 3 is 1. So really, these cancel out. So we tan of theta equals root 3. Now, thinking of your unit circle, tangent is y divided by x. You need it to be positive. So they either need to both be positive or both be negative. That happens in quadrant 1 and quadrant 3. Now the 45-degree reference angle is easy because it's either 1 or -1. So this needs to either be a 30-degree reference angle or a 60-degree reference angle. If we check what tangent of 30 degrees is, 30 degrees is √3/2, and the y-coordinate is 1/2. If you're doing y divided by x, you're doing 1/2 divided by √3/2, which is really times 2/√3. 2's cancel. You got 1/√3, which is √3/3. And that's not what we have. We just need it to be regular √3. So right there, you would know that it's the 60-degree reference angle. 60 degrees. The x-coordinate is 1/2. Y-coordinate is √3/2. So if you did y divided by x, it'd be √3/2 divided by 1/2, which is times 2/1. 2's go bye-bye. So you get √3, which is what we need. So we're looking for a 60-degree reference angle in both of these. And it says find all of them. Holy smokes. So 60 degrees in quadrant 1, 60 degrees. But remember, we need also the coterminal angles. So we would need to say plus 360n. You could say plus 360 degrees n, or you can just say 360n. So that's one of the angles. We're going to need that in radians as well. We'll do that at the end. Now, if we were looking for a 60-degree reference angle in quadrant 3, it would be 180 plus the 60, which is 240 degrees, plus 360n. So there are the two angles in degrees. We need to also list it in radians. So 60 goes into 180 3 times. So 60 degrees is pi/3 plus coterminal angles, another 2 pi times n, so plus 2 pi n. And really, you could have any variable you want. You don't need it to be n. 240 is 60 times 4, so pi/3 times 4 would be 4 pi/3 plus the 2 pi n. This lists every angle in degrees, in radians, and the co-terminal angles. Whoo! Careful. I know some of you were wearing your 3D glasses, and right there you're like, 2 more. It's a long video. Now this is radians. Okay. Let's get the signs on the same side. I saw the sign, and I subtracted from both sides sine of theta. No one's gonna drag you up when you get in a sign where you belong. Where do you belong? On the unit circle. Man, if you know that song, I bet you are laughing so hard right now. So hard. If you don't know that song, you just think I'm an idiot. Okay. We gotta subtract the 1, obviously. 2 minus 1 is 1. So where is sine? Sinoid. Where is the y-coordinate? 1. That's going to be at one of those quadrantal angles. It's positive, so it would have to be up here. Now, in degrees, this would be 90 degrees. But they're asking for it in radians. So remember, pi is 180, so it's half of that. So we're going to say pi over 2. Yeah. Yeah. Man, a lot of talking. I never do this much talking, even in real life. Okay, we're going to have to factor. We got sine squared, so let's factor. What do these two have in common? Well, they have a sine in common. So we can factor out our greatest common factor of sine of theta. Sine of theta times 2 sine of theta would give us 2 sine squared theta, plus sine of theta times 1 gives us sine of theta. So we just factored out a greatest common factor. Now we're going to set up our two equations. Sine of theta equals 0, and 2 sine theta plus 1 equals 0. Now, if you look, they're asking for it in degrees up there. All right, so here, sine of theta equals 0. We'll figure that out. That one's solved. We'll need to figure out the degrees here in a second. Here, we're going to have to subtract the 1. 2 sine of theta equals -1. And then we'll have to divide by 2. So sine of theta equals -1/2. So again, let's picture the unit circle. Sine is our y-coordinate. So where is the y-coordinate? 0. That happens here, because this coordinate is 1, 0. And it happens over here as well at -1, 0. So what are those in degrees? Well, over here is 0 degrees. Over here is 180 degrees. But technically, this could also be 360 degrees, which is included in the range here. So even though 0 and 360 are the same, we're still going to list them both because they gave us the range from 0 and including 360. All right, so here's where sine equals 0. When sine equals -1/2, if sine is our y-coordinate, we need one finger on the right. So that would be a 30-degree reference angle. But if sine is our y and it's negative, that would be down here in quadrant 3 and down here in quadrant 4. So a 30-degree reference angle in quadrant 3, 180 plus the 30 is 210. And in quadrant 4, 360 minus 30 is 330. So all 5 of these answers are included. Wow, that's it, right? Yeah, it's page 10 of 10. We did it. 58-minute video. We're done.